Hi guys, so today we're going to be looking at final review part 1. Let's start off with the first topic, which is simplifying exponents. Right here we're being asked to simplify 5m to the power of 3 times p to the power of 6 to the power of 4. I'll give you a few minutes to try this out on your own first. Okay, so the rule is whenever we have an exponent on the outside of the parentheses, that means that I want to distribute that exponent to every variable or number that I see on the inside of the parenthesis. So I want to distribute it to the p, to the m, and to the 5. When I do that, I get here 5 to the power of 4. We have m to the power of 3, which is to the power of 4. And we also have here p to the power of 6 to the power of 4. 5 to the power of 4, that will equal to 625. And then whenever you have a power over a power, that means that the exponents are going to be multiplying with each other. So we get m to the power of 3 times 4 and p to the power of 6 times 4. So as our answer, we get 625 m to the power of 12 and p to the power of 24 as our answer. Cool. For the next question, we're asking to simplify r to the power of 3 times p to the power of 6. And then on the bottom, we have r times p to the power of 2 to the power of 4. So to deal with this, let's deal with the bottom first of the fraction. So on the bottom, we have here r times p to the power of 2 to the power of 4. I'm going to get our exponent and then distribute it to the p and then also to the r. When I do that, I get r to the power of 3 times p to the power of 6. On the bottom, we have r to the power of 4, and then we also have here p to the power of 2 to the power of 4. When I do that, the bottom is going to change into r to the power of 4, and then we use the rule of power over power, which is to multiply the exponents, so we get p to the power of 2 times 4. On top, we still have r to the power of 3 and p to the power of 6. And that equals to r to the power of 3, p to the power of 6, r to the power of 4, and p to the power of 8. Then we want to deal with the fractions. So I'm going to combine the r's with each other. Since the r's are dividing, that means our exponents are going to be subtracting, which means that we get here r to the power of 3 minus 4. And then the p's, they're also dividing with each other. So we have here p to the power of 6 dividing with p to the power of 8, which means that we're going to get p to the power of 6 subtracting with 8. And so from there, that equals to r to the power of negative 1 and p to the power of negative 2. Because they're negative exponents, we have to make sure to change them into a positive one. So right now, there's a fraction where all of this is over 1. I need to move the exponents down here to change so that they change into a positive exponent. When I do that, I have here our fraction bar, and then we get r to the power of positive 1 and p to the power of positive 2. Since there's nothing on the top anymore, I could just write a 1 on top. So it gives our answer 1 over r p to the power of 2. That would be my final answer. Alright, let me clear this. And our next one is combining polynomials. First one is asking you to simplify 3y squared minus 7y plus 4, subtracting with negative 2y squared plus 8y minus 6. I'll give you a few minutes to try this out on your own first. Alright, so let's try it out. First thing I want to do is identify this negative sign. So since we have a negative sign, that means that I want to distribute it to every single term in the inside of the right parenthesis. A nice way of doing this is by imagining that there is a 1 right here. So you have negative 1. That's being distributed to the negative 2y squared, to the positive 8y, and to the negative 6. So negative 1 times negative 2y squared, that equals to positive 2y squared. Negative 1 times 8y equals to negative 8y. And negative 1 times negative 6 equals to positive 6. So our new expression here would be 2y squared minus 8y plus 6. So after I do that and I get the new polynomial, I want to combine any like terms that I see with the left polynomial. So to do that, I have to make sure that not only is the variable the same, but also the exponent. So I'm going to write down, the left side first. We have 3y squared minus 7y plus 4. And then underneath, I'm going to add the 2y squared with the 3y squared, subtract the 8y with the negative 7y, and add the 6 with the positive 4. And then I just combine things together. Positive 4 plus 6 equals to positive 10. Negative 7y minus 8y equals to negative 15y. And 3y squared plus 2y squared, that equals to 5y squared. That would be my final answer. Okay. Let's look at the next one. Next one is asking you to simplify 6y minus 7 times y squared minus 3y minus 4. When I answer this problem, I have to FOIL, which means that I'm going to get the terms on the left side of the polynomial and distribute them to each term on the right side. So we have here 6y multiplying with y squared first. We also have 6y multiplying with negative 3y. We also have here 6y multiplying with negative 4. 6y times y to the power 2, that equals to 6y to the power 3. 6y times negative 3y equals to negative 18y to the power 2. And 6y times negative 4, that equals to negative 24y. After I do that, I want to distribute the negative 7 to the y squared, negative 3y, and to the negative 4. So negative 7 times y squared. We also have here negative 7 times negative 3y. And we also have negative 7 times negative 4. Negative 7 times y squared equals to negative 7y squared. Negative 7 times negative 3y equals to positive 21y. And negative 7 times negative 4 equals to positive 28. So from here, we get all of our new answers. We have 6y to the power 3, negative 18y squared, negative 24y, negative 7y squared, 21y, and 28. And then I'm just going to write them all down on the bottom. So we get 6y to the power 3, negative 7y to the power 2, negative 18y to the power 2, positive 21y, negative 24y, and positive 28. Last thing to do is combine any like terms. So I see that we have negative 7y squared that can combine with the negative 18y squared. We also have 21y that can combine with the negative 24, and that's it. So as our answer, we get 6y to the power 3, negative 7 minus negative 18 gives me negative 25y squared. Positive 21 minus 24 gives me negative 3y. And then I just drop down the positive 28. And that would be my final answer. Done. Alright, let me clear it. And let's look at the last one. Last one is factoring polynomials. So for this one, we're being asked to solve for 0 equaling to 2k squared minus 24k plus 70. I'll give you a few minutes to try this out on your own first. Alright, whenever we're factoring, I want to see first if I can use or take out any of the numbers. So from 2, negative 24, and positive 70, seems like all of them can be divided by 2. So I can take out a 2 from all of them here. When I take out 2, I have the 2 on the outside, and then the inside of the parentheses, I'm left with k to the power 2 minus 12k plus 35. From there, I want to factor it out, and then if I could use the x method, I'll do that first. If I can't use the x method, I'll use the quadratic formula. So right here, let's try it out. We have 8k to the power 2 plus bk plus c. Our a value equals to 1, b equals to negative 12, and c equals to 35. So from here, I can use the x method. A times c goes on top, b goes on the bottom. A times c equals to 35, b equals to negative 12. A number that can multiply to get 35, but also add to get 12, is going to be negative 5 and negative 7. So from here, since I have my two numbers, I can create my new equation, which is k to the power 2, based off of the first term from our equation. And then we have our negative 5 multiplying by k. Oops. Negative 5, and it's going to multiply with k. Our negative 7 multiplying with k. That comes from these two numbers. And then our last number is going to come from the last term of our equation, which is positive 35. And all of this is also has the 2 here still. So from there, I want to see, or I'm going to split these into 2 different equations or expressions, and then I'm going to factor out a number from k to the power 2 minus 5k. Seems like they would both have k, so I could take that out. And then from the other side, I could take out a 7 from both sides. Let's do negative 7. So if I do that, I get here, I still have the 2 here. We get k parenthesis k minus 5. Over here we get negative 7, k minus 5 as well. From that, I want to check to make sure we get the same factor. And we did, because we got k minus 7 or minus 5 and k minus 5, which is good. So because of that, we can create our new factors, which is going to be k minus 5. That's the one that was exactly the same as the other. And the other factor is going to have the leftovers. It's going to have the k and the negative 7. K minus 7. And then we still have that 2 on the outside. So after we do all of that, we still need to solve for k. So to solve for k, I'm going to get rid of this 2 first, because it's multiplying by all of this here. So going to divide everything by 2. That would get rid of this 2. 0 divided by 2, that just equals to 0. And now we have left k minus 5 times k minus 7. So from here, I can split up out into two equations. We have k minus 5 equaling to 0, k minus 7 equaling to 0. Since k is subtracting by 5, I can add 5 to both sides. That would give me k equaling to 5. That would be my first answer. And then the second one, k minus 7, I can add 7 to both sides. That would give me k equaling to positive 7. That would be my second answer. Cool. The next one is asking us to factor completely 32r minus 2r to the power of 5. So I have to see what they both have first that I could probably divide from both of them. I could divide from both of them a 2 and also an r. So if I divide both a 2 and an r, I'm left with 2r, parenthesis, that turns into 16 minus r to the power of 4. So from here, I want to check if I can use the a squared minus b squared method since there's two terms shown here. And on top of that, if you can see here, we also have a subtraction sign that's shown. So whenever you see that there are two terms and a subtraction sign, that means that it's possibility that we can use this a squared minus b squared formula, where the new factored form of that would be a minus b times a plus b. So if that's the case, I want to find out what the a value is and what our b value is. So a would equal to the square root of 16. Square root of 16 is 4, and b would be the square root of r to the power of 4, which is r times r times r times r. So that would equal to 2 pairs of r, which would be r times r, and that equals to r to the power 2. So from here we get 2r, we have 4 minus r squared, and 4 plus r squared. Again, if we have two terms being shown and a subtraction sign, in this case there's an addition sign, so we don't have to even look at that polynomial. But right here we have a subtraction sign with two terms. We can see if we can still square root the 4 and the r squared. So if I have a, that would turn into square root of 4, that would be 2. For the r squared, we have square root of r to the power 2, which equals to r. So from here, we get 2r, 2 plus r, and 2 minus r. We have here 4 plus r to the power 2. And then again, since we have the two terms and the subtraction sign, let's see first if we can square root them. I can't square root 2 and I can't square root r, so that would be my final answer. Cool. Alright, so let me clear this. And that was the last one. So hopefully this helped. Good luck.